Okay, so now we're going to talk about errors. All samples are done, and surveys are done by humans. All experiments are done by humans. If humans are doing something, there can be errors. Okay? We've talked about before, what if the large counts don't work out? There's a chance there might be errors. They can work out, there still can be errors. People lie, accidents happen, people write down the wrong thing. Errors happen. Right? So once we form our hypothesis, we use sample data to decide whether or not to reject the null hypothesis. That's what we've been doing. However, just like a jury can reach the wrong conclusion in a trial, it happens. It is possible that we will make the wrong decision when we conduct a test of hypotheses. Okay? There's rules, there's laws. Juries can only hear certain information. Sometimes the information withheld would have changed the verdict, but they're not allowed to hear that. Then they get out and they're like, oh, did you know this? No, we didn't. I would have changed my vote. It happens. Okay? I was on jury once. We voted whatever way it was, the shoplifting case. We had a vote not guilty. But then afterwards, lawyers were like, well, we could have told you this. And I was like, yeah, we would have voted guilty then. But the law said you couldn't tell us that for whatever reason. Okay, that guy got away with it that time. Probably going to get caught some other time because he was pretty stupid. Okay, so in a trial, there's only two possible things that will happen. Convict an innocent person based on errors, convict an innocent person, or let someone, like I did in my case, who probably did it, go free. Which is worse? Is it better to let a person who's guilty get out on a technicality or whatever, or to send an innocent person to jail? Which is worse? Most people would say send an innocent person to jail because they didn't do anything. And the person who's guilty probably going to get caught again sometime. So in hypothesis testing, there are two possible errors we can make. A type 1 error is we reject the hoe, but it was true. Type 2 is failing to reject the hoe when it was false. So you have some empty boxes here you're going to fill in, and here's how it works. We reject the hoe, but it was true. That's a type 1 error. So we reject the hoe, and it was true. That's a type 1 error. If we reject the hoe, and the hoe was true, the ha was true, that's a correct conclusion. So either the ho true or the ha true. Ho. Now, if we fail to reject the hoe, and the hoe was true, then that's a correct conclusion. It was true, we didn't reject it, we did well. But if we fail to reject it, and the ha was true, that's a type 2 error. So there's two types, type 1 or type 2. All right, and just so you know, for this one right here, this is the alpha value. Okay? So for 0.05, that means a 5% chance of error. So we've had an alpha value of 0.05, we had an alpha value of 0.10. That's a 10% chance of error. There's a chance of error. Okay, so let's go talk about this problem. The USDA is going to be kind of gross. The USDA limit for contaminated chicken is 20%. That means they can send out chicken with up to 20% salmonella or whatever in it. Why is that? Because we're going to cook it, and that's why I say cook it to, that's why I use a thermometer for chicken and pork, because they do have this stuff in them. You know, steak you'll eat like half raw or bleeding on the plate. But with steak or with pork and chicken, you gotta be safer. You gotta cook it to a certain temperature. When you cook it to a certain temperature, it cooks out any of that 20% of stuff. But if it had 40%, that's not all going to cook out. So therefore, they have this rule. They can have up to 20%, but no more. A restaurant claims that the proportion of contaminated chickens they receive meets requirements. But there's a suspicion that they're not met. Why? Maybe people are getting sick of this restaurant. I don't know. Identify the null and our alternative hypotheses. Okay, so first off, what's our P? P is the proportion of contaminated chicken. What do we say bad chicken? Save time. Okay? Now, my hoe is P equals 0.2, 20%. My ha, P is not equal to, I'm sorry, not equal, is greater than. Is greater than 0.2. Now, so that's a good question. The reason it's not equal to is because it's going to be one or two things. It's either going to be more than 20% or less than 20%. This is up to 20% can be contaminated. So they're saying that their chicken is less than or at 20%. Some people are thinking it's worse than that. It's greater than 20% contaminated. Now, I could also accept this. And the reason I can accept that is, depending on how you read it, you might say, well, the restaurant is claiming less than 20%. Okay? So it's a good question. Why isn't it just not equal, since we could go either way? But it's not that it's either way, it's just how you look at it. Are you looking and saying there's more than 20% contamination, or the restaurant is claiming they have less than 20%? Okay? But either way, it's going to be above or below that amount. We're going to go for this purpose with this one, but if you went with that one like a quiz, I would accept it. It all depends on how you explain yourself. Okay, so what are the errors? Well, the error, first off, is this board. Okay, type 1 error. Okay, so remember, type 1 error is when we reject the hoe, but it was true. So if we reject the hoe, what you can do is kind of cover up the hoe and say, oh, I said P was greater than 20%. So you say that the proportion of bad chicken is greater than 20%. But actually equals 20%. Okay? So type 1 is you go with the ha, and you say it's greater than 20%, when actually it's just 20%. The hoe was right, but we rejected it. Now, what would that mean in the real world? If we said we thought the chicken was bad, over 20%, what would happen? Shut down, or what would happen to all the chicken? Have to throw it away, right? So here's the error. We made the restaurant throw away all the chicken, and it turns out it was okay. That's not great, is it? Lots of loss of money, okay? So there is one consequence, okay? So with type 1, lose money. Hold on. Don't get too excited. He's right there. Type 2. Type 1 error means they lose money when they shouldn't have, because the chicken was okay. We screwed up and said it was bad. Type 2 error is the exact opposite of this. So for this one, you just reverse this. So we say the proportion of bad chicken equals 20% when it actually is greater. Than 20%. So we say it's okay when it's actually bad. That's a type 2 error. So, if we say it's okay and it's really, really bad, what's the danger there?
Death.
Sick or death. Yeah, no joke. Okay? So, which one is more serious? Okay? It's more serious for that one because people may die. Now, does type 1 suck? Yes, because someone's going to lose money they shouldn't have lost. But money versus health, life, type 2 is worse. Okay, this one's not as serious. A company makes potato chips requires each shipment of potatoes to meet a certain quality standard. Not safety, just quality. If the company finds convincing evidence, I got it. Okay, so this is quality, not safety issue. Now, if the company finds evidence that more than 8% of the potatoes have blemishes, gross spots, brown spots, the truck will be sent back to the supplier to get another load of potatoes. Otherwise, the entire truckload will be used to make potato chips. Here's the hoe and the ha, okay, 0.08. Either it's equal to or greater than. If it's greater than 0.08, they are going to send the potatoes back. So they reject the potatoes. That's horrible, I know. Yeah, that's bad. Okay, so with P is the true proportion of potatoes with blemishes. Okay? A supervisor selects a random sample of 500 and finds 52 of the potatoes have blemishes. They're telling us right off the bat. They're doing all the work for us. The resulting p-value is 0.0240. Okay? So what conclusion can we make? Well, right off the bat, we have our p-value of 0.0240. They did all the work. And we have 0.05. So, less than or greater than? Less than. Okay? So, here's our paragraph. Since my p-value, 0.0240, is less than alpha, 0.05, we reject the hoe. Okay? We have convincing evidence. Same thing always. That the proportion of blemishes or blemished potatoes is greater than 8%. Okay? We have evidence that the proportion of blemished potatoes is greater than 8%. Okay? So, the type 1 and type 2 errors. Type 1. Type 1 is when we reject the hoe, but it was true. So in this case, we're going to say greater than, not greater than equal, we're going to say greater than 8% blemished potatoes. I'm going to kind of cut this short. Okay? It's just, we're saying that. When really was 8%. So, what was the consequence of that one? We said there were more bad potatoes than there were actually were. So what happens? They get sent back, right? And what happens? What's the sent back? What's the consequence of them being sent back? Lost money. The farmer loses money. Well, I don't know how much. You just got to take the bad ones out and send new ones. but he also has to pay for shipping, all that stuff. So farmer loses money. Now, type 2. Exact opposite. We say that the portion is 8%. When really greater than 8%. Okay. All right. So, what is the problem here? Well, for type 2, if we screw that up, type 2, love you too. Okay. So, type 2 error. Okay. If there's a type 2 error, we keep potatoes. Keep potatoes. Lots of blemishes. Okay? So if we keep the potatoes, and there are actually a lot of blemishes, we're going to have a lot of blemished potato chips. Right, so which one's worse?
Type 1. I guarantee you.
Type 1's going to be worse. Oh.
Type 1.
And here's where I will accept more than one answer. Type 1 is worse for the farmer. Type 2 is worse for the chip company. Well, okay, the chip company or the consumer. Good point. Because maybe some people don't like a lot of brown spots in their chips. So this is one of those things where you're not talking death versus money, so you could argue one or the other. Type 1 is going to be worse for the farmer. Type 2 is going to be worse for the consumer. Okay, real quick here. This goes really quickly. So, listen up. If A alpha is 5%, then we're using a testing procedure that will make type 1 error about 5% of the time. We already said that. That is, if the null hypothesis is true, and we were to take many samples and perform tests, and about 5 out of every 100, we would reject the null when it's actually true. So five times we'd be wrong out of 100. Not bad. Thus, the probability of a type 1 error is noted by the alpha. We already said this. New thing, the probability of a type 2 is denoted by B, the beta. Okay? We're conducting a hypothesis test. We choose the significance level of alpha when we have little control over beta. Common choices for alpha are 10%, 5%, and 1%. So 10 out of 100 errors, 5 out of 100 possible errors, or 1 out of 100. Now, there is an interesting give and take here, okay? Alpha and beta are inversely related. One gets bigger, other gets smaller. But, there's a huge but, not like 5, 95, 10, 90. So it's not exactly mathematical. If I go from 5 to 10, I'm not going to drop from 95 to 90. It's not mathematical. It's just when one gets bigger, one gets smaller. It's not mathematically related. It's just generically the size changes. So, last thing we're covering here. To choose an appropriate value for alpha, consider the consequences of making each type of error and choose the largest alpha that's tolerable. So 1%, 5%, 10%. So look at the judicial system. Alpha should be low since we would rather let a guilty person go free than convict an innocent person. This is ensured with the requirement that evidence beyond a reasonable doubt. Now, a pregnancy test. Beta should be low. Since it's more dangerous, especially for the baby, to be pregnant and not know it, than pregnant when you really aren't. Thus, you choose a high value for alpha. So let's look at that one, because this is more relatable and understandable. So, ho means you're pregnant. Ha is not pregnant. Okay? So, if ho is pregnant, ha is not pregnant. Let's think about this. If someone takes a pregnancy test, and they're told, it says they're not pregnant, but they really are, what's the danger there? They don't take their vitamins, they may drink, they may smoke, they may do a lot of things that would hurt a baby that they don't know is inside them. Okay? So type 1 is what we call a false negative. Type 1 is a false negative. So you take the test, it says not pregnant, but you really are. Very bad. Not advertised, just the test is wrong. Now, for type 2, it's called a false positive. It tells you you're pregnant. You go get all excited. You start taking the prenatal vitamins. You take it easy. And then, like a month later or 2 months later, you find out, oh, I actually wasn't pregnant. Okay? Things happen. So, a false positive might lead to disappointment, but a false negative could lead to deadly results or tragic results. That's kind of the definition of the word tragic. Okay, notice at the bottom of the page, not doing this. Okay? Scratch that out. Only homework is to work on the review, which is the next 2 pages, for the quiz, which is on Friday.